Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, we will be starting the hands-on implementation of SVM algorithm that we have covered up in our previous sessions. I hope that before coming to this specific video of code work, you already have watched my previous videos where we have discussed the foundations of SVM, uh, how and why basically this kind of algorithm is being used. Everything I have discussed so far theoretically. And I think today is the right time that we will talk about the code work for the same. What are the algorithms or the functions that we have in sklearn, with the help of which we directly, implement the algorithms of SVM in case of classification task also, and in case of regression task also. So without wasting any time, let's get started. So now let's start the implementation of SVM from scratch. So here what we will do is we will try to take that wine quality data itself, which we have used for decision tree implementation. I hope that you're already aware about that data, that that was a multi-class classification kind of a task, where we will be having a target value available as the quality of the wine, given the set of features, for example, citric acid, sulfate, alcohol, and so on. So let's try to use that same data and we'll see that how can we implement a SVM classifier on top of that, okay? So at the very first stage, obviously we have to import all the required frameworks. So let's do that. Let's import all the required frameworks here. So what we will do is we will import NumPy as NP as an alias name, right? We will import pandas as PD. We'll import matplotlib as PLT and seaborn as SNS. Now, once it is done, what we have to do as a second step is definitely to load the entire data. So we will try to load the data. So how can we load that? We will say data is equals to pd.read_csv. And what is the path of our dataset is this one, right? So what I'll do is I'll just try to copy this path. And after this, we will try to see the head, which is the topmost 5 records available in this same data set. So you can see, right, this data contains features like fixed acidity, volatile acidity, until the alcohol part. And the target column that we have is the quality. Means at the end of the day, what we want our model to predict is the quality of the wine, given these input features. Now, I hope you all remember the EDA portion we have already discussed in our initial modules. So that is a point to note here, that I'm just skipping the EDA part. So EDA part or EDA implementation is skipped in this pipeline. So that is your task. You have to do it on your own, because I already have talked about EDA a lot. And if I will do the implementation of EDA in this specific file itself, so again, it will take a lot of time. And I really want you guys to practice that EDA stuff rather than me doing for the different files that we are working with, right? So please do it at your end. Try to see the outliers available or not. Try to see whether the class is a balanced class or not. If not, you all know, right? How can we handle the problem of outliers? How can we handle the problem of imbalancing of a given data? So please try to handle it as per the knowledge which you have gained in the entire course till so far. Now let's move ahead. Now in the upcoming part, what is the next task? Next task is to do the data splitting, I would say. So in data splitting phase, the very first task is to split the data into, you can say, input features, and you can say target variable, or you can say target feature, right? So how can we do that? We will say x is equals to, we will be having a data dot drop, which is quality, which is the column name. X is 1. After that, y is again the target feature that we have. I think this is fine. So now if you will be able to observe, x is the input features that we have, and y is the target feature that we will be able to gain. Now in the next part, we will do a data splitting, but here we will try to split our data into training and testing phase. So we will split the data into train and test set. So how can we do that? We will say from sklearn dot model underscore selection, we will just try to import something called as, I think, train underscore test underscore split. After that, what we're supposed to do is we will try to split our data. Random state, we can take it as maybe 44. Anything you can take. So what we have done is we have tried to train our data into training testing in the ratio of where test size will go towards 20% from the entire data. And I hope you all know, we already have discussed that this random state part indicates that we will be able to have similar samples in the training and the testing phase at every iteration of running this code file, right? So what we will do is we will try to first of all run this part, and now we will be having a training testing set available with us. The next important step that I'm planning to do here is feature scaling, because it's quite important, because it might be the case that few features in this given data will be having a bigger scale as comparable to other features. And if we will not handle that phase before data modeling part, what will happen is my model might be biased towards those features which are having a bigger scale as comparable to those features which are having a smaller scale value. So I think feature scaling is important. So let's do the feature scaling. And to do that, here I'm using the standard scalar. I hope you all know standard scalar will try to convert the entire feature set into standard normal form. When we are saying standard normal form, what is the meaning of that? It simply means that mean is equal to 0 and standard deviation is equals to 1, right? So what we can do, we can say from sklearn dot pre-processing, we will import standard scalar, right? And after that, we will just try to do a fit underscore transform in the training set and transform in the test set. I think we already have discussed this reason also, that why in the training set we are applying fit underscore transform function, and in the testing set we used to apply transform function, because when you are saying fit underscore transform, in the fit part it will try to take the entire features that we have, and what is the mean and the standard deviation of the given features that we have, it will try to take that. When we are saying transform, then it will apply a z formula, which is xi minus mu by sigma, and transform the entire feature set into that particular values. In the testing part, there is no need to again do the fitting, because we already know the value of mu and sigma. So with the help of that specific value, it will transform the entire testing set. So now you will be having a training and the testing set available with you. Now, once it is done, I think now we are in a situation where we can go for data modeling. And for now, I am using the SVC classifier for the data modeling per se. So what we can do is we can say SVM classifier, and here the model name is SVC. Definitely, I think we need to import this before loading this particular data set. So sklearn.svm, from sklearn.svm we can just import SVC, and after that you can see SVR was also there. If let's say you are working with a regression specific problem, so instead of loading SVC, you have to load SVM. Now I'll show you the documentation also for the same, so that we will be able to understand that part in a very much apt manner. So SVC classifier documentation, let's open that. Yes, this is what I want to open. So if you will be able to see, there are multiple parameters that we have in this SVC. So C is the coefficient kernel. I hope everyone knows. By default, it is RBF, degree, gamma, coefficient 0, shrinking, and so on. By default, for now, what I'm doing is I'm trying to just take the default parameters and will try to fit my data on the training set. So SVM classifier.fit, the training set, that model we will be able to get. After that, I want to see the predictions of my model, and the score I will see later on, maybe not here, right? So what we will be able to get here is this. Right? So we will be able to get the predictions of the entire data that we will be having. Now you can see the score also by passing the test set. and you will be able to see that the score is almost 62.008%. Also, you can compare this score with the decision tree classifier that we have made, that whether the score is better or not, right? But now we can also work upon in order to get the better optimizations done by getting a better values of the hyperparameters that we have. And for that, definitely we have to do something called as hyperparameter tuning. Now, in order to do that, either we can go for grid search CV or we can go for randomized search CV. So if you remember in my last discussion, I have given you a task of doing a randomized search CV on your own. So today what I will do is I'll try to showcase you both of the stuffs, and then you can verify that whatever work you have done in your previous task is correct or not. Okay. So what we can do here is we can just try to first of all set few parameters. So now what I'll do is I have a list of parameters available with me. Okay. So I have tried to create a grid of parameters. For example, if you can see, we have C as the value, kernel as the value, gamma and degree as the value. So what I have done is I have tried to apply multiple, you can say values which I wanted to just judge and let me know that which one is the best parameter for my SVC classifier. So here is our param grid which is available. Now, let's say if you want to apply a grid search CV, so you can see, right, the code is automatically coming up. That's the beauty. So here you can see that we will be having sklearn.model_selection. So this is the pipeline to apply, you can say, grid search CV to get the better, or you can say the most optimized parameters. So we are just trying to import the function name grid search CV, the model name is SVC. Or what you can do, you can just also apply this SVM underscore classifier because you already have this classifier available. And then you can apply parameter grid. And once you will just run this code, it will take some time. And after that, it will try to provide you a complete set of the best parameters which we will be able to get. Again, just you have to work upon, yes, grid search dot best underscore params underscore. And what will happen is it will try to give you the best parameters for this part. And then maybe you can just look into it and accordingly you can retrain your model, right? So it is done. You can just try to check. So as per the grid search CV, it says that if you will take the value of C as 1, the degree as 2, the gamma as scale, and the kernel is RBF, then your model will work perfectly fine for this wine quality data. Same thing, if let's say you want to apply the randomized search CV. So what will happen? You can again take this randomized search CV, apply this SVM underscore classifier. And once you will fit this data, and again, if you will just try to find out the best parameters, you will be easily able to find out random search dot best underscore params. So this, as per the randomized search CV, it is saying kernel is RBF, gamma is scale, degree is 2, C is 1. So in both the cases, we are getting a similar response as per the best parameters. So what you can do is now you can just try to create your model. You can just train the model with the best optimal parameters now. So what we can do here is we can just try to create a SVM classifier, or maybe you can say underscore optimized params, right? And you can write the same naming here as well. And then maybe we can just try to see the score, how basically it is working. C is 1, right? C is 1, gamma is scale, kernel is RBF. Let's do the retraining again. Done. Optimized params ka score kitna hai? Let's try to check that out. So if you will just see the score on the basis of the tests that we have, X test and the Y test, and if you will just try to run this code, you will be able to get the score. Almost, I would say it is equal only, right? Is that default one is also RBF, C is 1, and the gamma is scale. That's why it is equal. Because when we are applying this, optimizations, hyperparameter tuning on the grid search CV, somehow it is showcasing me the similar results. Acha, degree also it is showcasing me to as 2. What is the default degree? Default degree is 3. Then might be there will be change. So what we can do is, apart from this parameters, we can say degree also as equals to 2. Let's see now. Does that impact? Now it is, I think. Or is it same only? It is approximately same. See, the major reason might be, which I can see here, is because the maximum parameters which we are seeing here is approximately equivalent to the documentation default parameters. And that's the major reason that when we are applying the default parameters versus when we are applying the parameters given by the randomized search CV and grid search CV, we are getting almost similar kind of a result. But this is the complete flow. This is where you need to see that how the complete pipeline of SVM classifier implementation will be done. If let's say you are in future trying to solve a problem where you will be having a problem of regression task, so instead of just calling SVC, you have to call SVR. So I'm just trying to showcase you the documentation of SVR as well. And you can see where it is varying, support vector regressor. So if I'll just open this documentation, you will be able to see we will be again having a kernel, degree, gamma, coefficient, the value of C and everything. It's just that here the implementation is just based on the kind of a problem which is having a regression kind of a scenario where the target variable which we have is a continuous number. So this is the overall idea. And now because you're solving as a regressor problem, so in that case you will try to work upon getting a mean squared error or RMSE value. In this classifier per se, again that is your task. So please try to create a classification report, right, in which the complete, you can say classification report, in which you will be able to get the accuracy, in which you will be able to get the recall, precision, and many more stuffs. So if it's a classification task, so this is where you will be able to get a proper evaluation that, okay, how your model is behaving. If it's a regression based task, then obviously your model evaluation metric will get changed to MSE, RMSE, R squared, adjusted R squared kind of a score. So this is the overall idea behind this implementation. I hope that you will be able to get the clear-cut idea, because everything from scratch I have done in the live implementation itself. Still, if you have any confusion, please do try to reach out to me via email or via my LinkedIn. So now I hope that you will be able to get a clear-cut idea behind how can we implement the SVM algorithm in machine learning. With this, let's end this specific module. In the upcoming module, we will discuss some another amazing algorithm. Might be K only, K nearest neighbor algorithm. So please stay tuned, and I'll be looking forward in the next algorithm towards talking about again the mathematical intuition followed by the implementation for the same. I hope that you are enjoying this course till so far. Kindly share your feedback as well. And if you have any sort of doubt, any confusion till so far, you can reach out to me via my email or via my LinkedIn ID. I'll see you all very soon in the upcoming videos. Bye bye everyone, and see ya.